Assalamu alaikum students. Today we are starting our lecture 4 of our online classes, and the topic of today is problems related to vectors. We will discuss different problems, numericals of chapter of vectors. So let's start. Okay students, so let's start with the problems, and the topic is representation of vector. The first question we have of this topic, the question is draw the following vectors. We have to draw the vectors, and the first question is force of 3 Newton acting towards north. If you have this question, you have to draw this vector graphically, and for graphical representation we first select a scale so that we can draw this on a paper. So I take here 1 centimeter is equals to 1 Newton to represent the magnitude of the vector. So it means 3 centimeter line will represent 3 Newtons. Okay, as it's given over here, we have to draw a vector whose magnitude is 3 Newton. And for the direction, we have reference scale over here that shows the directions of north, east, south and west. So we start, let's say we start our vector from here. Okay, now we have to draw a line of 3 Newton. It means we have to draw a line of 3 centimeters and in north direction. So with a suitable scale, we draw a line over here like this. Simple as that. And this arrow shows the direction. It's going in the north direction. This is the north direction, upside. So this will be north over here. So this is the answer. But make sure you have to set the scale and reference scale for direction as well. So you can write over here 3 centimeter or 3 Newton both, because you have set the scale over here. Clear everyone? Okay, moving to the next problem. Okay students, so next problem is we have to draw a displacement vector of 20 meters in 45-degree direction. So first of all, we set a scale over here. A suitable scale is, I took 1 centimeter equals to 5 meter. It means if I multiply by 4 both the sides, so 4 centimeter will be equals to 20 meters. We don't need a direction scale over here because the direction is given here in degrees. So we just have to use a D for taking this direction. Let's say I start drawing my vector from here. So first of all, I have to take the direction. We always take direction from horizontal, or you can say x-axis. From here I take an angle of 45 degrees with the help of a D. So I guess this is an angle of 45 degrees, and I draw a line of 4 centimeters. 4 centimeters line to represent this displacement vector. Okay, that's it. So this is a simple question, this simple problem of representation of a vector. Clear everyone? Now let's move to the next problems. So students, here we start the problems of the topic addition of vectors. As we saw, there are 3 cases for addition of vectors. The first one is when the vectors are parallel. Number second is when the vectors are perpendicular, and the third one when they are in random directions. So first of all, in these questions we have to judge whether the vectors are parallel or perpendicular or in random direction. Then we can apply the solution to that. So I am just drawing a diagram to clear this point. Let's say I make the first vector, I draw it over here because it's in east direction. So it's going over here. It's 3 Newtons acting on this object, and on the same object a vector of 5 Newtons is acting in the same direction, and it is of 5 Newton. Also another vector acting on this body, it's of 4 Newton, but it's directed towards the west. So it means this is the case of parallel vectors because they are parallel. These vectors are parallel to each other. So we apply the method of vector addition when the vectors are parallel. What we do, for the resultant, we just simply add the vectors or subtract them. The vectors in the same direction are added, like f1 and f2 are added, and we subtract f3 from them because f3 is going in the opposite direction, which is of 4 Newton. We just put the values over here. So after adding and subtracting, the resultant is 4 Newton, and the direction should be in the direction of the big vector, and that is in the east. So this is the resultant vector of these vectors when we add them. Clear, everyone? We just simply add or subtract vectors by simple mathematical rules when they are parallel to each other. Okay students, so in this case we see we have to add these vectors. We have two vectors over here, and to judge whether they are parallel or non-parallel, first we draw a rough diagram to check. The first vector is going towards the east direction, so I draw it over here. It's of 3 newtons, and another force is acting on the body towards the south direction, which is over here. It's of 4 Newton, because as we see, north, east, south, west. So it means these vectors are perpendicular to each other, so it's the second case. And how we add these vectors? We draw like this. The first vector, we put the second vector on the head of the first vector like this, and the resultant would be starting from the tail of first vector and ending at the head of the last vector. This is the resultant vector, and for this resultant vector we have a formula for its magnitude. This is the formula. We just put the values over here. And we get the value 5 after simplification. But it is just the magnitude of the resultant vector, not the direction. For the direction we have another formula, or we can just calculate this angle with the help of a D. So this resultant has a magnitude of 5 newtons when 3 Newton and 4 Newton forces are acting perpendicular to each other. How we add them? We first take the first vector and put the second vector on its head like this, whatever its direction is, either north or south. And for the resultant, we start our resultant vector from the tail of first vector and end at the head of the last vector. So this is the resultant. For its value, for its tail, for its magnitude, we have this formula. We solve it. Okay students, so here we see another questions in which we are given with 3 displacement vectors and we have to find the resultant of these. So first of all, to check which case question is this, we start, and since the displacement we have to go in a proper sequence. First we draw the first vector which is in east direction, and the scale we have over here, let's say 1 centimeter of our scale will be equal to 1 meter of the question. So it means 5 meter will be equals to 5 centimeter. 3 meters in the second vector will be equals to 3 centimeter, and 4 meters in the third vector will be equals to 3 centimeter. Now we start it. A vector is going in the east direction, a 5 centimeter line, or you can write 5 meter. Then from here we go to 30 degrees. We take an angle of 30 degrees over here, and we draw a line of 3 meters only. 3 centimeters. This is the second vector, and from here 4 meters, it means 4 centimeter line towards the west, somewhere here. So it means these are neither parallel nor perpendicular vectors. So this is the third case of vector addition, and that is head to tail rule. And the same way we added vectors, we put the first vector, then we put the second vector on the head of the first vector, and the third vector on the head of the second vector. Now for the resultant, we start with the tail of the first vector and the head of the last vector. So this will be the resultant vector, and for this resultant vector we can only use a scale to measure its length. Let's say its length is 2 centimeters after measuring from scale. So according to our scale, 2 centimeter will be equals to 2 meters, and for direction we take D and find its angle. Let's say 2 meters at 30 degrees. Most probably this is 30-degree angle. So this is the third case of vector addition. When we have random vectors, we just add them with head to tail rule. Clear everyone? Okay students, so this is the last question, and the topic is rectangular components. So in this question we are given with a vector along with its direction, and for direction we are given with some angle. Like here we have to find the rectangular components of a vector given by this. This is a velocity vector, that's why it's represented by V, and its magnitude is 30 meters per second. This unit should be appropriate. Like if we are talking about the velocity, then the unit should be meters per second. Since velocity is a vector quantity, so that's why we are having an arrow on it, and the angle given is 60 degrees, and we have to find its components, the vertical and horizontal component. So for the x component, which is also called horizontal component, we have the formula. Since v is the vector, then its x component will be vx. So here the formula for vx will be v cos theta. The way we had for fx f cos theta, for vx we have v cos theta. So we put the value of this v, it's basically the magnitude given over here, it's 30, and the angle over here is 60 degrees. So we put this angle with cos, and we first find with the help of calculator this value cos 60, and it's 0.5, and then we multiply this with this 30. So we got the answer 15 meters per second. This x component of the vector is 15 meters per second, Vx. Alright, clear everyone? Why we are not mentioning the direction? Because the directions of these two components are obvious. That's why we have resolved our vector into horizontal and vertical component, because the directions are obvious. Clear everyone? Now for the y component, we have the formula for any vector. Let's say we have a vector v, so its y component will be called vy, and its formula will be v sin theta. Here we put the value of v30, which is given over here, and we put the angle 60 degrees as same we put in the x component value. So by the calculator we find the value of this sin 60, and it is found to be 0.866 approx, and then we multiply it with 30. So the final answer is 25.98 meters per second. Here we can see that the y component is more than the x component. And why is that so? Because the angle is 60 degree. It means this vector is more leaning towards the y-axis. So the y component would be more than the x component. And the same way, if we add 15 and 25, approx 26, the answer will not be 30 degrees. It means we cannot add these vectors by simple addition to find the resultant. We have to apply some head to tail rule in that. Clear everyone? So these are the topics for addition of vectors, and this topic is rectangular component. So I guess we are clear with this chapter now, because this was the last topic of this chapter, and we will join again with some new topics. Thank you.